Hello everyone, my name is Kirti Chandra and welcome to my YouTube channel Architectural Education. Today we are here to learn about topography, a part of microanalysis which is generally done when a student or a person is actually dealing with the physical data of any site. Let us see a brief detail about topography. Topography, the word itself is telling you topo and graphy. Just to draw a place, that is nothing but topography. Here you can see a place which is there in which is having some undulation over here in the form of a ridge or a mound or a mountain. So just by drawing it on a piece of paper in the form of a plan, we can actually see what kind of gradient it is going towards and how it is having a very steep slope over here. You can see in the elevation section which is drawn over here. With this way of representing named as topography, we can actually see a lot of activities which are on the surface of Earth. These drawings of topography are generally made by Survey of India, Dehradun, which are authenticated throughout the India. These topographical features not only the mound or a mountain but also the valley which is available over there, and hills, mountains, are there any lake which are in the form of water catchment, even those are being represented in this topography. The process of making these topographical contour details or contour intervals are based on grid references and interpolation method. In this video, we will not get into the detail of how these contours are being laid on the plan, but we will focus more on how these contours can be interpreted as an architect to utilize it for their design. As I already said that we would not be getting into the detail, but on a broader aspect, we will see some of the important features which we might utilize in our upcoming slides. So first one, imaginary lines. These contours are nothing but imaginary line. It should be drawn in dash 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 format. But here I have drawn in a continuous solid line. The reason is for me to hatch and fill the in-between spaces in AutoCAD and Photoshop. Otherwise, this should always be in dash 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 line, as they are imaginary lines and they are above the main sea level. They are always above the main sea level. The main sea level is considered as the zero, and then currently the Hyderabad is located approximately at 500 meters MSL. That means 500 meters above the main sea level. When it comes to contours, there are two important factors which are always a part of it, like slope and gradient. If you see it in detail, slope and gradient. Slope represent the percentage how much it is, and gradient represent the ratio factor 1:2, 1:20. So that means for every 1 meter we have to go around 20 meters to maintain the ratio of some percentage, that is 5%. In other words, we can also say that slope is a scalar, whereas gradient is a vector. If you see the slope is magnitude of inclination, whereas gradient is magnitude of greatest slope. So that means the slope is there throughout this area, but the gradient will be drawn at one particular point. Let it be any point, then the gradient will be drawn at one particular point. A very brief rules which we have to follow while we are doing the topographical analysis in terms of contour. Same contour lines indicate same elevation points. Contour lines eventually connect to themselves on a holistic approach. Imagine that we have a site in which we have a contour which is running in this direction. So assuming that the line is stopped at the boundary wall, so the actual contour line will metaphysically connect to the same contour line in another holistic approach. That means at a larger or a macro scale, the contours will always be in a closed loop. These contour lines never cross each other, and at the same time they do not show any diversion over here. As the levels are same, that cannot be happening. So what happens is, probably the level will be having two different lines. When it is splitting, it doesn't split, it actually has two different lines which are very close to each other. So here on a broader things, contour lines are the lines which are existing over here. Contour interval, this is the interval between two contour lines. And another topic, that is major and minor contour. In major and minor contour, what happens is, for example, here you can see in this image that 10, 20, 30, 40, let it be feet or meter. So what is happening, there is a gradient which is there, and there are around 4 lines which are there in the form of contour. Imagine if there are around 40, then will it be possible for us to do it or analyze it to the detail? Yes, it will be slightly difficult. So in that case, what we do is we make the major contour at every 5 or 10 divisions, and then minor contours will be filled in between those 5 or 10 divisions. So for suppose this is 10, and then comes is 20, and then comes is 30. So in between there are 10 contours, so there will be 9 contour lines which are running. So in between 20 and 30 also there will be 9 contour lines, which indicate that the minor one are smaller intervals are the minor, and the major intervals are the major contour lines. The next stage starts with the interpretation of site based on topography. So what we can interpret from any site. The very first thing comes is the relief map. Relief map shows us which one is the higher location and which one is the lower location, and what is happening in between, how the deviation is happening. In the last session I have told you that no contour lines are breaking, they are just getting connected at a holistic approach. This is one of the example for which. So now coming back to the point of interpretation, let us first see the relief map, and then we'll start off with the slope analysis. This is one example of slope analysis in which we can see that the slopes which are very steep and the slopes which are very gentle, how they are managed to get the output. Next comes is our hydrology pattern. As you can see, there are ridges and there are valleys and there are ridges over here. So this gives us a glimpse about how the water is flowing in the site and where are the points where it is getting collected. We'll definitely see into the detail of this part. Next comes is the vegetation. In vegetation, we will see there are two different aspects. One where you collect the information from the Geological Survey of India or Google Earth, and the second one where you are presuming it where could be the possible vegetation or buildable areas. Next one is the geological pattern. We will also find, based on the ridges and valleys pattern, we can definitely find the areas which are more suitable for buildable and certain areas which are having fine or coarse sand. First one is relief map. Relief map, this is represented by the contour lines. This generally helps us in understanding the variations in the elevations present over there. The same sketch can be helpful for us in understanding that there is a height over here, and then there is a slope, and then there is a depth over here. If you see the Hyderabad elevation model, we can find that these are the areas which are at a higher surfaces, and these are the areas which are at a lower surfaces. And if you see the actual water movement over here on a broader aspect, the central line is the Musi river. We do have other rivers over here, other lakes over here, and this is the Hussain Sagar lake. Now coming back to the point, this region is around 600 meters above the main sea level, and the white one is much more than around 640 meters above the main sea level, and the lowest portion is around 460. So in that words, we can conclude that the Musi river is around 460 meters above the main sea level. You can see over here also that how things are over here, where the contour lines are there, and at the same time you can see the lower lines which are represented with light green, and the higher elevations which are represented with dark green. Little bit detail about how we can work out with. So for any site, what happens is we can actually take the site and we can divide the site into different contour intervals. Here in this example, we can find that we have divided the site with so many contours. The highest one is 502 and the lowest one is 495. So now here what is happening is anything greater than 502 I am putting it to the lightest white, and then 502 to 501, which is somewhere over here, and then 501 to 500 somewhere over here. You can also see this thing over here. This is from a reverse direction. Let us start from here only. So 502 to 501, 501 to 500, which is over here, and so on. So what is happening here, we can see a clear picture that this is the highest point and this is the area in which the slope is going, and this is the lowest point based on the color indication given over here. If you see a step-by-step procedure of it, what I have done is I have first identified the contour lines and I have put the contour intervals over here. Then I have given a gradient to it. That gradient I have given based on the color. Here actually I have used grayscale. In your thing you can actually use a variation from bluish to brownish with a mild tints and shades in between, or in other words you can only give a brown color tint or shade from top to bottom. But please do understand that the highest level will always be in the light color and the lowest color will always be in the dark color. So now coming back to the point, in the second step what I have done is I have given color codings to it. Then third step what I have done is I have given the lowest level of color to these location first. So it gives me that these are the areas which are located at the lowest point in third stage. Now fourth one what I have done is I have actually started filling up the remaining portion wherever it is there. The remaining portion was somewhere around this level. Fourth one. Now coming back to fifth one, in fifth one I have slowly added colors over here. Sixth one I have added colors, seventh, eighth, ninth, and finally we have got the 10th one, in which the whole site is being surrounded by contours and it is clearly representing which one is the higher point in the site, and this is also the higher point. If you see this map we cannot identify that this is the highest and this is the highest, whereas once we see the relief map we can easily catch that this and this maintains the highest location and the central portion maintains the lowest location in your site context. Example of the same drawing. This is for Delhi JNFU. Sorry, this is for Delhi JNU, where you can see that this is the highest elevation, which is somewhere around 780. So 788 to 780, you can see this, and you can see I have marked it with yellow, and slowly I have marked it with. So once what happens is when this color shading happens, then we can easily identify the one which is necessary for us, and so on. Now coming back to the point, this is the highest point in your site and this is the lowest point in your site, and at the same time you can also see that the lowest point is giving a curvilinear shape over here. So what is happening over here is that this is starting to form a kind of water body, which we will see in the next session. Next session starts with slope analysis. Slope analysis is one of the important aspects to understand where the buildable spaces are there. In most of the site what happens is there are certain areas which are having steep slope and certain areas which are having very gentle slope. So in such cases this analysis will help us in identifying which are the regions are having steep slope and which are the regions which are having gentle slope. Most of the times what happens is while analyzing the slope, we will not only understand the gradient or the slope at which it is there, we will also understand the geomorphology, that means how it is being created over there and what are the other aspects of soil and rocks and other things and how they are there. So if we see, the slope analysis is slightly different when compared to the process how we have done it in relief map, where we have just added multiple colors within the slope. Now let us see. Here what we are supposed to do is list out the requirements of slopes required specify to your site. For example, we might require building, driveways, landscape areas, play courts, etc. As you might be thinking, yes sir, most of the times it is required. So at certain areas the building ratio or proportion would be much lower. For example, if your guys are designing some structures where the built up area is very less, like a resort or a cottages. Okay, resort is a cottage. So or any such kind of activities where the building area is lesser, at that areas it will be much helpful for us. So we have to first identify the requirements of our site. Next one, identify the slopes required for such activities. We have to identify what are the slopes required for a building, what are the slopes required for a driveway, what are the slopes required for a landscape area and play court. Don't worry, in the next slide I'll be explaining you what are the slopes required for it on a general basis. You can definitely cross check it with TSS, and wherever you find alteration you can imply it in your designs. Identify the slopes required for each activity. Demarcate the slope on this site plan and represent the slope percentage in the form of a legend. So we'll definitely see a best example out of it. So this is one of the aspect, and this is another aspect. As you can see over here, this is the highest point and this is the lowest point in this one. So what happens over here is, if you see over here, the distance over here is much larger, much greater when compared to the distance over here. So that means what happens is, this is having a steep slope and this is having a gentle slope. The same scenario applies in any direction, whether it is a valley or a ridge. So here what happens, this is a gentle slope, whereas here you can see a steep slope. This is one of the drawing which explains you with the color code. This is given over here green. Sorry, so the drawing given over here is less than 10. So we can find the areas which are having less than 10. And the second one is greater than 10 but lesser than 20, which is in the form of blue color, which we can see. So that is why how we can actually put it. So if you see, this is the actual formula for it. G is equal to D by L into 100, where G is the gradient. Gradient you generally know that it is in the form of a ratio, 1 is to 20 or something, where 1 will be the depth and L will be the length of it. So if you see any slope which is over here, we can always find that it is having a depth and it is having a length over here, which forms in the form of a triangle. So what is happening over here, for example, this is 1 and this is 20 meters. So the gradient is around 1 is to 20. So here in this scenario what is happening is, we are taking 1 is to 20, for example. Now here G is equal to D by L into 100. Many areas, many countries, the formula will vary. For example, at certain countries gradient is equal to rise by run into 100. At certain countries it will be vertical height by horizontal distance or contour intervals. So that will be there, not contour interval, sorry, horizontal distance between 2 points in a contour on two different contours. So don't get carried away by them. The formula core idea remains the same, but on a broader aspect we can see that 2% till 2%, that means from 0 to 2, it is generally understood that most of the areas are not having exactly zero level, but we generally presume it to be lesser than 2% slope, where we can provide lawn, driveways, play courts and buildings. Most of the things can be done over here. This complication slowly starts when we have 2 to 5%, where it will be slightly difficult for us to build the building. Now here comes a contradictory question. Can't we build a building at 5%? Yes, we can definitely build it, but it is not suitable for that land. When the land is restricted or limited, then we can actually build it over there. In other words, if you can say, we can build a building right in a water body also, but that is not economical nor feasible nor environmental in that way. So the one which is supporting majorly is we have to consider. So another slope which starts from 5 to 10%. We can generally use it for driveways or landscape areas. Landscape areas includes greenery, green pockets, or any kind of OAT activities, open air theater activities, or any stage activities, and so on. Now, last but one comes is 10 to 15%, which can be utilized for landscape areas in the form of concert area. Next one is 15 to 25%. From here on, after 15, we have to be a little bit precautionary. We can use it as a part of steps, or you can use it as a part of vertical circulation or trekking or any such activities. But we have to be a little bit precautionary at this stage. And anything beyond 25% is actually a prohibitory act. It is always better not to take any initiative at certain those areas and leave it as a reserved landscape. But when the space is restricted, as usual, you can even construct a building at such areas. But economically, environmentally, it is not a viable answer to that. This is one more example where we can see lesser than 2% and then 2 to 5%. In lesser than 2%, you can identify that are the areas. 2 to 5%, you can identify that these are the areas which are more suitable. And 5 to 10% then comes is somewhere over here. These are all the color codings which are there for 5 to 10. 10 to 15, we can slowly come towards a little bit darker side of it, and then greater than 15%. I have given you the activities which are required in this one in the previous slide only. Now next one, hydrological pattern. In this part of site analysis where we are learning about hydrological pattern, we are not going to cover the underground water aquifer movement or underground water table. We will be working more on surface movement of the water. In this type of hydrological pattern or site analysis, what we are going to do is to check the movement and collection point on the surface. For example, if this is the way of the slope and then the land is going like this, if the topography of your site is something like this, so what happens, here is the water collection or water movement, and here is the water collection. So we'll be basically identifying this channelized movement and the collection points which are having over here. To understand any further, we'll be focusing on four aspects: ridges, valleys, knolls or mounds or depressions. Ridges, these are actually water converges which are happening over here. If you see, this is the highest and this is the lowest point. Generally, how I go ahead with is just to draw a line parallel to this one and assume you are having a point in the center. Now draw a line perpendicular to that. So when you draw a line perpendicular to that, that is the way how the water flows. And when you draw over here, which is line parallel to it and then draw perpendicular to it, then what happens? We will find the water flow of water over here, and the water is actually diverging over here. So when the water is diverging, what is happening? This is the forming in the form of a ridge. Whereas when you draw the same line over here parallel and then you draw a perpendicular line, and here also when you do the same thing, what is happening over here? Sorry, actually I have drawn wrong over here. So when it comes to, this is the higher and this is the lower. So at this point what happens is the water will be going perpendicular to the contour line. Here also it will be going perpendicular to the contour line. If you extend this and when you check it over here, you will find that the water is actually converging. When the water is converging at one point, what do we call it? We call it valley. And when the water is diverging, we call it as ridge. So here you can cross check it. Ridges are the one where the water is diverging, going in two different directions, whereas valleys are the one where water is converging. Now next one, knolls and mound. As you can see over here, this is another one where you can find that the highest location is over here and this is the lower portion. So when you see it in the form of a section, you find it that this is a kind of mound, or in other words mountain, or something which is hilly. So we can call it as a knoll or a mound. The same thing when you see this is the higher line over here and this is the lower line. So what is happening over here? There is a depression forming where the water gets collected over here. Now when it comes to interpretation for your site context, every site is having unique features over there, so it is very difficult for us to generalize this, but the concept can be understood. What are the aspects that you need to study? What will be the outcomes of those study in your site may vary as per your understanding, as per your detail of study what you are going to do. So on a broader thing, we can understand ridges, valleys, mound and depressions. These are a hydrological pattern. Now how to draw this? As we can see, we have to first start with identifying the ridges over here wherever are they, and then we have to start working on the valleys. As you can see that the ridges are the one which are showing a concave portion for the light color, whereas the dark color, wherever there is a concave portion for the dark color, those are the valleys over here. So this is a valley and this is a ridge over here. You can see it with a color code of brown color as a ridge and blue color as a valley. Now the same thing next starts is with the depression. The depression can be found certain areas over here, here and certain areas over here also. So we can find the depressions. Now what is the use of a ridge? The ridge is used where you will find the toppest layer at the site. And what about the use of valleys? Valleys are generally the points where the water gets collected. And what about the water bodies? Water bodies are the areas where water gets collected for a very large period of time. For suppose there is a rainfall and the water has to accumulate at certain point. So these will be the points. So at these points, do you construct any building? Obviously not, because what happens, the water might get collected. Unless you are having a theme that you would like to make a perennial resort kind of area where you want the water to get collected and people come up with other means, then it is okay. And last one is knolls and mounds. You can also see certain areas which are knolls and over here. So this is a very simple site for any landscape architect, but when it comes to complicated site, it will be much easier for us to understand, which we'll see in the further. So here what have we seen, that these are valleys and these are ridges over here. So the water will get collected over here and finally these will be the highest locations in your site. So in this example, what I have done is I have identified the major ridge over here. Then I have identified another ridge which is intermediate. Then I have identified another ridge which is minor ridge over here. In your case, you can only find main ridge and main valley. But if you have so much complications, you can actually try to find out the one which is main valley, intermediate valley and the minor valley. It depends upon you, because the more you do the detail, the more you will have points which will be helpful for you. For suppose if this is one of the ridge and valley, so in that case you find that there is a ridge over here, there is a ridge over here, and these are all valleys. So at any point of time, will you construct anything over here? No. Why? Because there is a huge collection of water which is being collected right in front of the building. So will you construct it over here? Maybe, because there is only a very small channel. So will you construct it over here? Never. Maybe because there is a huge water line which is coming, which is gathering a lot of valleys, and then the water is being deposited right over here. So this will be the use of ridges and valleys for any site. Next one is vegetation pattern. In this vegetation pattern, we can actually study the existing or the possible vegetation. Existing vegetation, we can learn it from many websites, or we can even go to Geological Survey of India or bhuvan.nrgi, and at the same time you can directly go for a survey to the site and identify the location and canopy of any tree in your site. And at the same time we can actually look the another alternate for it. It's not an alternate, it's an addition to the existing one. So possible vegetation where you can propose, but this can be done based on hydrological study. So for suppose if there is a valley lane, so the possibility of mineral deposit over there will be much higher. So what happens, it's always a better chance to provide the tree in the valley area, which will not only utilize the water to the maximum extent, but also make sure that the groundwater table is recharged, and at the same time it will stop floods. These locations can be more suited for plantation as it contains high fertile rate. Since there is a lot of deposition happening over there, the rate of fertility will be much higher in these regions when compared to others. Now, in this vegetation pattern, we can go ahead with two steps. One is the one where we are finding the existing one. In existing one, we can find out the details through survey. This survey generally is done by the government or at a private source. For the students, I can suggest you like Google Earth or OpenStreetMaps, where you will get free details about vegetation, networking, and other things. Next one is applicable. The applicable will be done based on the hydrological pattern which you have just done before the vegetation. Here are two of the examples where I have put the Google Earth. I have actually generated the map over here, plan over here, and then I have put the plantation of these things over here. And second one is the for the same site, but here I have done based on the valley points. The existing one, in existing one you can find that I have put the Google and I have started putting plantation at each and every point at its location, and the final outcome would be something like this, where I can find that the trees are there over here. Now next one is the applicable one. This applicable one, what I have done is based on the ridges and valley drawing, that is the hydrology pattern, where I have taken valley and I have given an offset of 5 or 10 meters based on the site visit. And what I have done is I have produced a outer line for the proposed vegetation. Now based on this, what will happen is I am not saying that I will not build anything over here. So what I am suggesting is I have identified a location which is having more suitability for good fertility in land. So ultimately what happens, any area in landscape which is requiring for me to make park or garden or any kind of such green pocket area, then I would like to suggest it to be over here. It may be constructed over here, or it may not be constructed over here based on the approach, network, and many other design aspects, but at this stage I would prefer it to be over here. Next one is for geological pattern. In geological pattern we can find soil patterns or boulders, rocky sheets, or any kind of morphology for geological anomalies. So what happens over here is this geological pattern, we might find certain areas where the soil is very fine or the soil is very coarse, or there might be boulders, there might be rocky sheets. All these things, when they are documented at one drawing, what happens over here is we can overlap this with other drawings which we are going to do as composite analysis in the last sheet. So when we compose all these things, and we can find out that what is the buildable and non-buildable spaces. So this area helps us in identifying not only the buildings but where the plantation could be there, where the play courts, horizontal network, or any obstruction which can be considered. For suppose if you are designing over here, this is your site and this is your one block, this is your another block, and you find that there is a rocky sheet in between, so you can actually provide a nice movement over here. But if you find that there is a boulder in between, you have to take a turn over here, so you might actually relocate the building over here once you know, but until you know this, it will be slightly difficult. At many stages, at a little bit higher level, you will have other facilities to learn, other uh, parameters to learn. For example, lineaments or ground aquifers, such things. But at bachelor's level, I would suggest you to go with mild patterns, whatever I am suggesting. Now, next one. There are two ways in which you can find out about the geological factor. So one is the existing one and second one is the applicable one. As usual, what we have done in the vegetation pattern, it goes with the similar lines, where in existing one you will do a survey by going to the site, and then you can get the details from it. Or as a student, I can suggest you also to go to Geological Survey of India physically or through website, or you can also log into bhuvan.nrsc.gov.in, where you will get all the details about the geological pattern. These websites will not only give you the current geological pattern but also help you in understanding the formation of such geology. Generally we call it as geomorphology. Next one is the applicable one. The applicable to best and suited buildable and greenery in the site based on hydrological pattern. Here also what happens is we'll identify the valley and give an offset of 5 or 10 meters, where we will understand that these could be the fine soil pattern over existing over there on the site. So based on this, what happens is we can presume that the site is having. So here you can see that these are some of the details which you can get in existing survey. Now let us start with an existing. If you go to the website Bhuvan, as I already said you can find that these are the areas. You can see Hussain Sagar, or this is the map of Hyderabad. You can see Tangband over here, and then there is a water body, Musi River over here. You can also see what kind of soil is over here. That is their denudational origin, pediment, pediplan complex. Now, if you want to go in detail, you can actually find out the morphology on which it is been labeled over. Next one is application. In application, as usual, I have taken the hydrology pattern over here, identified the valleys and given it an offset to say that these are the areas which are having fine soil. Now, what does this indicates to me? When this is fine soil, obviously the other areas the possibility of coarse soil is higher in these regions. So in that way, I can understand that these areas are more helpful for me in construction, even in terms of soil pattern. So if there are any complications which we could find in the existing one, that there is a boulder or there are rocky sheet over here, those can also be applied over here to come. Now finally, composite analysis. Composite analysis includes everything whatever is there. It starts from relief map to slope analysis to hydrology pattern and any other kind of uh, geological pattern existing over there. You can find that there is a relief map over here. You can find the hatching with in the for the slope analysis. You can find the hydrological pattern with ridges and valleys over here. You can find the vegetation existing over here. You can also find the geological pattern, that is the rocky outcrop over here. Now once all these things are combined, we can come down to certain conclusion that these are the areas which are more suitable for building. These are the areas. Now what happens is many times for any student it will be given that 10 acres of site is given or 100 acres of site is given for them. So in that case, it is very difficult for us to place some 10 meters by 10 meters or 20 meters by 20 meters of information center right in the middle of 100 acres. So in that way, what happens? In that case, what happens? This composite analysis or this pattern or this process of site analyzing will help us in reducing down the unnecessary or unwanted spaces. So here basically one way we are trying to find out the best suitable space for construction, and in other way we are cutting down the non-suitable spaces for construction. What are the non-suitable spaces for construction? Valleys, rocky outcrop, dense vegetation greater than 10% and so on. Now finally, we'll just revise a small detail about each and every aspect. Relief map we have used for identification and demarcation of land which is higher and lower. This is the very basic thing. Next one, slope analysis, where we have seen the complexity of site topo by using the gradient over here. G is equal to D by L into 100 was the formula which we have done. Hydrological pattern, surface drainage. What did we do? Ridges, valleys, knolls and depressions. And next one is vegetation pattern. In vegetation pattern we have seen the plantation possible and the one which is existing over there. And finally geological pattern, where we have seen fine and coarse boulders, rocky outshoot, rocky sheets, etc. So these are there, and combining all the things, what did we find? We have found buildable spaces and open spaces which can be used for any kind of activity. All about. In today's context, we have covered topography, we have covered interpretation of site based on topography, what are the aspects over here, and how we can go ahead with this thing. So coming back to one last point, these analyses are helpful for you in understanding the site and giving it as an option and reducing or understanding the complications of the site. Many could raise a point that I have done a design which without doing all these studies also. Yes, you can do a good design even without doing it, but it is always helpful for us to know the site before we start working on it. So this could actually give you a creative idea in terms of uh, spatial planning or in terms of circulation when you know the site to the best extent. So these are the topics which we have covered in our YouTube channel, Architectural Education, and thank you. See you in your next video.